So today we are going to continue our last class. Last class we understand how we can define my custom types and how we are able to associate a defined method for the custom type. So last class say, hey, if you want to define custom type, and here said it's employee, and using the struct keyword help us to define the type. So type we can define the different way. In coming classes we can understand, but as of now we are going to define our custom type, maybe employee, and construct tell us define the data or field, which fields they have. Let's get this field having maybe id, let's and maybe it have a name, maybe it have age. Okay, so this is the way. So here naming convention say capital letter and a small letter. So there are some differences. So Go language not have any kind of a specific keyword. This is the public variable or this is the private variable. So Go language say, hey, any type name that is your kind of capital letter. This means accessible from outside, okay. And if you can say any variable that is the lowercase, that only accessible within a package. So in this main package all these variables are accessible if you are writing in the lowercase starting. This is the lowercase. If you are starting with a capital letter, that means this employee or id or name can be accessible outside of the main class. So here a small letter and capital letter define your accessibility, where these types or where these fields are accessible or not accessible. Okay. So this is the way you can define the constructor. So last class we say once you define the type, how we can use them. So here you can say, hey, bar, let's say employee 1. What are the types of? This is my custom type. And even how to initialize, you can say, hey, I am going to initialize with the whatever this type employee, and the same like struct syntax here, and here you can pass your name id, maybe id1, name maybe John, maybe here name is should be 54. So in this way, and let's print them. Okay, not responding. Okay, so here they print them and say, hey, employee 1 equal to comma employee 1. So this is the way you can define your custom type, and you can create the variable of employee types and initialize. Even in one line, yeah, you can just declare and here say maybe E1 employee 1 equal to this. Both are okay. So last class we discussed in this way we can initialize, and if you print them, you are getting the complete your response. But this is the one way, but generally we are doing shortcuts. Say, hey, instead of this I can say, hey, e employee 2, let's I'm going to employee 2 directly. You can say shortcut here, hey, this is the way I'm going to assign this, maybe employee 2 John 2 and age maybe 42. Okay, so in this way you can define maybe your employee 2 employee 2. So these are the last class we discussed. This is different way where you can define your type and declare the variable. But in a Go language, can instantiate or create object or instance of this employee types is the multiple way. Okay, so last class we discussed this, and even here the only notice here, whatever the order you pass, id, name, age, similar kind of order you have to pass. First this is the id, this is the John, this is the name. You want to change the order something, then you have to specify the exact field name as well. As so even similar kind of things you can do. Let's employee 2. So here say that's I am employee 3. Employee 3, I can say here let's say id, the colon id, this is the employee 3. Even you can maybe pass later, maybe here any order you can say. Here it is the age, okay, and here you can say this is the name, okay, and this is your employee 3. So this is the way you can also create the employee instance using this direct. You can pass the value, but ensure that you passing the same order which you declare here, but you have some different order. You have to mention the name and value, names and value, names and value. Okay, so why not running? Let's run it. So but this is the one way, and there are couple of way as well. As you can may can say create the instance of this is the one way. Even you have some pointer variable, you can use this address operator. Let's like here, maybe you can say, hey, I am going to see the address here, so add address. So here you can create maybe 3 id 4. Okay, so in this way you can create the object of employee using this address operator. When this is the pointer variable, you can say. So these are the different way you can create the object or instance of your custom type. And even we have one more option, even like E5 employee, and you can say I am going to using this new function, new, and specify, hey, here is the my employee. So in this way you can just instantiate one employee, and here say this is the 5. And but here what is the name? So here you have to specifically set, hey, E5 dot you can set id, and then name, and then age. Here say id equal to, let's 6 5, and even you can say dot name Smith, and even you can say dot age. Why not come age equal to 56. So in this way also you have option, you can create the employee object. Okay, so there are a couple of way. Directly you can create the pointer variable, or simply so let me, why code is somehow not running. So let's run it. You can say these are the couple of way where you can say whatever you define custom type using the help of a struct. Is custom type can be created with a different way. This is one way by the struct. Struct means you have to define the concrete value type, what the data, what the field you are going to store. Sometime we can define our maybe custom type using the interface, or using the any specific predefined types as well. As So those also we have option. So we're going to, but today we not we have to understand we can create the instance of employee in a different way using the new function, maybe using the address operator, maybe using this your complete naming convention, field name and value, or directly you can say value instead of the field name. Even you can write the constructor function for them, and that will also help us. So instead of writing this way, you can write one function that can create the employee object. So you can generally say, hey, I am going to write one function, and function name like new employee. Here you can say, hey, I need the id uh, id as a integer. I need the name as a string. I need a age as an integer. And here say, hey, I am going to return your employee. Somehow my system is very slow. Employee, and here you can pass your id, your name, your age. And even what the return, you can return, hey, I am going to returning pointer of employee. Okay, so that in future anyone want to update, modify employee. Okay, and here you can say, hey, return the address using this. So whatever the things we have did here, like maybe using this address operator, maybe direct, yeah, this any this way you can write the custom function. This custom function, hey, this function you can call and they create one employee object. And so here you can also say, hey, okay, so this is the way. And here you can directly say, hey, I can create maybe your employee 6 using my new function, new employee function. New employee, here pass id maybe 7, name would be Tim, and age would be 73, and you can just print this employee 6. Okay. So there are different way you can say it. Generally as your preferences, you can make instance of your custom type in a different way. All are the okay, depend upon your convenient in a use case, your application. You can run it. Why not running? Something happened? No. Oh, right click, run code. Where is running? Where is running? Not sometime due to the code is already running. Due to my system slowness, somehow we are not getting the output. Maybe we can run from the command prompt, go run go. Code already is running, code already running. My system is so slow. Sorry. What is going inside? So let's open the command prompt. Let's open this command prompt. CMD. Somehow my system is not performing well. Okay, and here simply run go run dot. Okay. And here you can just open it. In this we can also get the output. So objective is that today we have a Go language provide the option different way you can create the instance of any of your custom types. So let's wait. What is happening? Still compilation going on. Finally open it. Okay. So these are the way. So I say sometime this type is the different flavor. You can create your custom type using a struct, or sometime you can also create the type for a specific function only. A struct is generally used to define the concrete type, but I can also define my custom type for the function. Maybe generally in other programming language you can say interfaces. Okay, so let's do how to define those. Let's check the. So notice we are able to get some complete output. Okay, all are good. So let's think how we can define interface. So similarly, like here similarly you can say, hey, this is the my type, and type maybe any kind of type, maybe maybe calculate, maybe calculate, and this is the interface. And interface say here struct say you can define the type for the struct, means here you can define your field. Sometime you can, hey, here I can define the function, maybe some function. Okay, and that return maybe integer. Okay. So sometime you want to define interface type. In this case, you is the only you have an option to define function. Here you cannot define any kind of a variable or field. Maybe some 1, 2, 3, whatever the case. Hey, it will take a 2 parameter and return something, whatever the calculate something, or area, maybe shape area. Maybe you can say, hey, maybe calculate area, maybe shape, any kind of. Okay, so maybe calculate shape. Okay, shape interface, and shape have a shape interface, and shape interface have a, let's calculate the area. Okay, calculate the area. Okay, and that's nothing return. We return void, we return calculate number or float or string, whatever the. Okay, maybe return a string, whatever the, you can define the data type here. String. So I'm trying to say whenever you are going to define custom type you can define for the construct. That means you have to specify your field value. For custom type, maybe shape, with the help of interface only define your function. Here he can define the function only. Question is that this function how to implement. So notice here we can associate any function, like yesterday we discussed, you can write any function and receiver type which is employee, that becomes. Similarly here you can write any function that have this syntax, it will work. Maybe let us we define the type maybe rectangle struct. Okay, this is the my rectangle type, and this rectangle type I can go write the area function. Here say, hey, I'm going to write function that receiver would be the, this is the receiver, this is the receiver rectangle, rectangle, okay, generally prefer pointer, and this same function you can define here, okay, and here just return return what return, just return rectangle area, whatever the area you have. Image logic business is right. So in this way you are trying to say, hey, this shape interface implemented by this rectangle, maybe square. Similarly you can say, hey, the different kind of you can say here maybe triangle, and you can say, hey, this triangle can be implemented by this interface. So now this is the shape interface is implemented, means the definition of this method is provided by a different implementation or structure, maybe struct, maybe type, any types. Maybe here you have a, because here this is the only definition where the business logic, where define the function. This is a defined function here, this is defined function here, it's the triangle area. Okay. So question is how we can use them. So maybe you have a, let's say like a function, general function, then print, calculate size, maybe area, shape area, okay, shape area. This will like a shape interface. This is your shape interface, shape S is the shape type, and here say, hey, I'm just say, hey, shape dot my area. Okay. So this function, if I'm call, I can call any object that have a area function implemented. So here your rectangle is implemented area, we can call. This is your triangle, we can call this as well. So here say, hey, come here. So let's just comment out everything. Okay. So here say, so now here say, hey, I have a maybe rectangle, okay, this is my rectangle. Maybe we have our triangle equal to triangle. Okay. The different, in this way you can create this, and here say, hey, I want to call my this function, which is I define here shape area, okay, this is my function. So here I can call my function shape area, and we can pass the area of rectangle, shape area, we can pass the rectangle triangle. So this is the way you can also define your custom type for the function. We are function 1, function 2, function 3, and these functions are implemented, are provided by the some your concrete class, maybe rectangle, maybe triangle, anything. So what they are saying, what somehow. So here you can pass the calculate area, they receiving the your shape, and shape is the interface, this rectangle already provided this your implementation. Similarly here, okay, let's run it. So this is the way how we can define our custom type using your struct or using your interface as well as, or any predefined your existing library. So whenever you define using the struct, and whenever you define your custom type using the interface, So here you can define the concrete variable field value which allocate memory to store the value, right? But in the case of interface, we only define the function that's not directly allocating any kind of memory. Okay, these functions are provided by the specific your concrete type implementation. Okay, so sometimes someone asks, hey, what are the differences between the custom types of struct or custom types of interface? Interface is just for your set of function, and this function can be provided by the any kind of types. But case of custom types like your struct, here you have an option, you can specify any specific field or blank, that's open. But here you have not any option, you can provide any kind of fields, right? Okay, what say? I cannot or say yes, implemented the same. Okay, so here say why say s dot shape is implemented by this rectangle. This is the rectangle, let's rectangle, we can call r, maybe rectangle r. Here we can say this is the area, this is a triangle, struct triangle types, and they can implement this shape. Yes, we can do shape, maybe star. No, we can pass, it will pass by say cannot use r as a variable type rectangle shape value in the argument to shape area. Rectangle does not implement the shape area pointer as a pointer somehow. So let's go with simple. Then that's a simple pointer. Okay, and I think it's okay. Okay, so we'll and here you can then run it. So these are the different way you can say, hey, we can implement interface. This is the interface, and we can implement by the different rectangle. So only major differences, you can also create a custom type using the struct or custom type using the interface. So interface is just for your method, and this for your here. If you're trying to, let's compile and run it. Okay, now it's okay. There, everything is okay. I'm not printing anything. Something. Okay, 1 minute. Why say I say start area, they are returning, but we are not printing something. Okay, so let's whatever this here write the print, because they return the value. So here say, hey, print function, just write here, hey, calculating the area, whatever the area you have. Okay, and just print them area. So in this way you call this this is you can say runtime polymorphism. Is can call the s dot area, which area depend upon which object. Here you pass rectangle, they calculate the rectangle area. Here you can call triangle, they calculate the triangle area. Okay. So these are the somehow many places in our code base you can found how to. Sometime there is one more concept here, like in other programming language, kind of inheritance. One object already exists, we can use the same object in our or not. So notice here rectangle area, triangle area, then okay, very good. So here let's say now let us we have a kind of a complex, like one of it maybe type super type, maybe one is the super type. Okay, super type. Okay, super type let struct. Okay, and this is the, let's have a variable one variable super. Okay, and similarly one we have a type sub, that is also struct. Okay, and here say variable a, let's say here say here variable b. Okay, okay. So here sometime let's I want to use this super class in the subclass as well. So we cannot there is no any kind of inheritance in the like other programming language. So whatever the one object, already we have a super or a type object, and one I'm going to the take subtype object. Subtype means our objective, whatever the defined here, this should be part of here inheritance something. So we in the Go language we cannot offer kind of inheritance here, but you can offer up a composition. We can compose them. We can use this super inside your sub as well. So here instead of this, so you can simply say hey this is the, so let's this is the super type object, okay, super, and this is your sub. Here say hey this is my super, I can directly use this super. So what happened, this subclass subtype already have this both, they have a and b. So how to use this, how to create the object of same as we did for others. So let's comment out and here say hey we have a s equal to your sub, and notice here we have a two thing, one is the super and one is the b. So here you can pass, so two-way initialize, hey go ahead and here say one is my super, whatever the name we have a super. So here say hey we have a super, and super say super, and here whatever the value a, let's get 10, and similarly here we have a b value 20. So in this way you can use them. Okay, and even generally prefer you can use the last comma. Okay, or you can also simplified version, you can say hey and let's print them. So your s equal to, okay, and even you can sometime, as you know, you can just omit this, just not needed, just pass the value, just give remove the and just remove the, it's also works, let's say as well. Okay, okay, so in this way you can whenever you are going to use the composition, so whenever you're going to subclass object like here, then whatever the composite object you can say, you can complete create here, then create, and even here you can access the variable of like h1 dot and whatever the like b or super dot a, like here you can access a, even you can access the b, and even you are able to access a dot super and then dot a in this way. So all the way, this is the dot a, dot a, this is the dot b, this is the dot super dot a. So all the member you can access them. So composition, here in this Go language prefer composition over the inheritance. Inheritance means whenever we have one types available already variable declare, and I am going to declare another variable, I want to include all the fields here as well as. So generally in other programming language inheritance, here say whatever your super type, you can directly use here. Here we cannot specify any kind of types things, just mention your complete your type. Okay, you can also do like in this way, you can do like this way as well, but this is the like a SSS. So this is also possible, but generally prefer for composition. This is the way your complete object. Here just we can different two kind of, this is the type of this is the type of this, two value we have to set here. So these are the object composition. You are composing sub object with the help of your super object. So whenever in the Go language you are going to, hey, I want to test my inheritance, so you can use the composition. And how to create the object? Just you can create the super class, there is no problem, but subclass you can create your complete detail and this here, this way or this way, any simple way. And from this object you can access maybe this variable, maybe this variable, maybe this variable. Okay, this is the way even you can compile and run them. So sometime you have a kind of methods. So notice here, in this case, you can shape area, you can pass only those which have implemented this area interface. It's okay. But what happened here, if I am going to pass some different object, maybe like here we already have a sub object. So let's create one other object like super, and here say a equal to 40 and say, hey, sup s2. Okay, and is I can pass this s2. Here we cannot pass s2 because here say s2 is not implemented. This s2 means super is not implemented the area function. If it allow, they are going to call here s2, and this in this function you are going to call area function, and area function is not defined by this your class super. So somehow this is not possible. Okay, so if we can do something like generic, so we'll talk more about generic later part, but please ensure that whatever the value you are going to pass inside a function that expect some interface, so those object or instance must be provide the implementation of this interface methods. This is the contract, means this interface you must provide. But somehow maybe you can write the generic interface like save for all, and here say just call directly interface. So here generic interface and here now this is the you can call for all. Okay, save for all comma yes. So what the meaning here? So sometime you can write your function that take a specific interface, and sometime you can write a function that take not a specific interface, just blank interface, just interface here. You are not specifying any function. So this function, whenever you're going to call this function, here even you can pass r, even here you can pass t, even you can pass s2. Maybe here let's create s2 equal to super a colon 45. So notice this is the super, right? Yes, so super class. So in this, notice this shape all, here you can pass any kind of types because this function take the s and just like uh, types of interface. And here we have a lots of benefit. This is, you can say, just empty interface, just a generic, not because there is no any kind of implementation required, because this interface but no any method say look like. So here if sometime you want to make a generic method, this blank interface can also help us. And blank interface has some specific feature we are going to talk later, but yes, this way sometime you can write a function that take an interface, and that interface have some specific function. So whenever you're going to call them, you have to pass this specific function. And but sometime you have to define a function that have a blank interface. In this case, you can pass just like a any kind of object. Okay. So whenever I'm writing compiling, you can super save. So hope this will you are able to understand the defining custom type, maybe with the help of interface or with the help of a struct. While the struct, we have to provide the specific field only that hold the value that required the memory. But in the case of shape, this is just a function you can declare it, and this function is must implemented by the specific type, maybe type rect, maybe strangle, any those type must have a defined a method for the particular shape interface, so that you can use the shape. Due to that, here I am able to properly use this rectangle or triangle, because both have defined this shape interface. Define means whatever the functions defined in this interface, similar kind of syntax you have to write with this receiver of the particular type, right? So in this case, that means this rectangle is indirectly implemented the abstract method or interface method here, but there is no direct implementation in a Go language like other language. Okay, so just the way any interface, any class, anything you can say, any have this kind of a behavior, any function that take no input and return a string, that is the implementation of set interface. This interface is not bound to a specific type, a specific construct is only implement any kind of. What thing? S2 cannot be type again something. What is happening? Let's check. Something, any problem? No, I have already done. S2, S1, S2, S. Okay, here. Okay, so let's comment out. But we can do. This is also possible. Okay, it's working. Due to my slowness, it's working. It's working. It's working. Everything is working. Okay. Notice we can call the here save for all, save for all, save for all, save for all. Right. Good. So in this way, let us go do the practice of this, how you can define your custom type with the help of a struct. A struct means you must define some field. That field required memory allocation, and you can create the employee object, maybe your constructor function or the different way. And similarly, you can define your constructor type using the interface, but interface only define your function. Here you cannot declare the variable like uh, while value types integer. This is not allowed here. Okay, so let's say no, what say, notice expected found That's okay. So generally it is not allowed due to that, say, hey, we cannot find this syntaxes. So if here you can write any function, maybe area, maybe parameters, and you can define that returns any kind of function. So any function you can define, but whenever someone going to implement, they have to going to override those. Here any number of parameter, this interface maybe you can declare the float. Okay, float 32, float 64. So interface can have a many number of functions, and any interface you can use them, then you can define them. Okay, so notice here, say, hey, this is you cannot call because they are not define the missing method parameter. So somehow whenever you are defining the multiple function, your this rectangle must be implement the both function. This is the this, and this is for this parameter as well as this is the parameter. Okay. And similarly this is also must defined by your rectangle and triangle interface. So please ensure that interface, now here you can in your function it's allow, hey, allow, you can now you can allow call them, you can allow call them. So here you can say like simply you can say here, or you can say now you can say your, hey, s dot your parameter. In this way also you can call them. So please note that whenever you are defining interface, if multiple function you are mentioning, ensure that your implementation are provided with both in concrete implementation provided with the both function, so that you are able to access them, you are able to call them, right? Again, what's saying this, it should box cannot are the type of rectangle as shape in the argument shape area, rectangle does not implement shape, wrong. For the parameter string, okay. So here notice they say ki here you can define a parameter but returning float, but here you are returning the string. Yes, if you are returning a string or float, you have to mention that whatever your proper return types. As of now you can just calculate, but for learning we can just say whatever string, so that I can return any specific message or any return float value you can do. But it's please ensure that whatever the implementation you are doing, you follow the complete syntax. What is the method name, input types, and return type. Similarly, your method name, input type, and return types. And in this way, you can call them. Okay. So this is the way you can test them, or you can implement them. So please be note that sometime we are defining our custom type with the help of interface, just for maybe dummy implementation without any kind of method or with a specific function. But construct, similarly you can define any field or without any field, but this is for your field, this is for your function. But you can define your you can say custom types with a different way, like we study struct, like we study interface. So let's do the practice if and we'll still continue the more concept in case of your Go language. And we also discuss we can use this composition, this is also known as a embedded object, you can say embed, how to embed an interface, embed any kind of struct or any kind of types. So somehow this many places this embedded composition you can say or use help us in the case of our, right? So let's it's a good, and we'll continue the next class. Thank you for watching for this video.